Okay, in this video, we are going to look into interfacing your microcontroller project onto a network, a LAN, a local area network. And the device we're going to use is this one here. This is our interface. It's a UART TTL to Ethernet converter. It's made by eByte. The part number is NE2-T1B, and it's available on Amazon. Okay, I'm going to demonstrate how we could interface the PIC microcontroller that's on board the Scamp 3E board onto the network. So the UART output of the Scamp board is fed into the UART to Ethernet converter, and I have two LEDs that monitors the TX and RX coming out of the UART from the Scamp board. And there's a power light you can see on the top. That means the power is on. There's another LED down here. It shows you the link status. Now I don't have anything plugged in, but as soon as I plug in Ethernet cable, you'll see the LED come on the bottom, and it's blinking, so it knows there's a cable connected. It's blinking, but it's not linked. When it gets linked up to the my computer, it'll go solid. So I'll run Telnet on my computer, and then we'll watch that LED, and she'll go solid as soon as we link up to our program. So I'm going to use putty. So I'm going to Telnet into the board using putty, and as soon as it links, she's solid. So now I have Telnet running on my computer, and I can gain access into the Scamp 3 board. And I'm not using the USB connector. It's redirected to the UART, to the serial port. So we get access now to from the Scamp 3 board via the serial port instead of the USB port. Okay, my breadboard is powered externally with 5 volts. You can see here, there's your plus and minus. That's fed into the VIN of the Scamp 3E board, and the 3.3 volt regulator now is feeding power to the UART to Ethernet converter. And you can see my power light is on, and my link light is solid, so I'm connected to my computer, Telnet. So now I can gain access to the Scamp board. If I hit enter on my keyboard, you can see the LEDs showing that it's seeing the TX and RX. If I want to turn on an LED, I go LED on. It turns on the LED at the very left. I can turn it off. Turns it off. I can turn on the first 8 LEDs on the string. So if I go 255 LEDs, you can see they came on, and I can turn them off. So you can see I gain access to the Scamp board through a network connection. Okay, the default IP address of the UART to Ethernet converter is 192.168.3.7/24. Now /24 means the first 24 bits is a network ID. So the network ID is 192.168.3 and the host ID is 7. So the /24 means the subnet mask is 255.255.255.0. Now to configure the UART to Ethernet converter, you don't need a microcontroller. Just plug it into a breadboard, power it up with 3.3 volts, plug a cable into the Ethernet port here into your computer, run Google Chrome, and you can gain access into the converter because it is hosting a website. So in the URL on your browser, just punch in 192.168.3.7. You'll get access into the converter for configuration purposes. Okay, I have Google Chrome up and running on my computer, and I punched in as the URL 192.168.3.7, and this is what I got. So username is admin, password is admin, that's default. So we hit login, and there's our menu on the left. So IP config, we'll leave that as default. IP address 192.168.3.7, the mask. We go to socket A, TCP server, and local port is 23, that's Telnet. Socket B will be the same. Here's our UART. So the baud rate 115.2K baud, 8 data bits, no parity, 1 stop bit. And we'll go down to the very bottom, save config, go OK, and it's done. It is now configured. Okay, to gain access to the converter using Google Chrome, you have to put your computer on the same network as the converter. So go to Control Panel, select Network Connections, and find your Ethernet port. and select it. Go to Properties, select Internet Protocol version 4 and Properties, and there you'll put in the IP address. Use the following IP address, 192.168.3.4. So it's the same network ID, but you're going to put in .4 for the host. And then the subnet mask is 255.255.255.0, and then hit OK, and it shall be configured. Now to gain access to the Scamp board over the network, you could use a program like PuTTY or TerraTerm. I'm going to use Zoc. It's another program I use, and it's set up for Telnet. So if I go File and Quick Connection, and there's my IP address, 192.168.3.7, port 23, and I'm set up for Telnet. So go Connect. So it's connecting. So now when I hit Enter, I'm in. I'm connected to my Scamp board as if I was connected to the USB port. So if I type some words, we'll go about. We can type words. There's all the words. There's all the I2C devices. There's how much memory is free. So basically we're into the Scamp board over a network connection. Now on the Scamp board, you have to write a turnkey program to redirect the USB console to the UART 1. And to do that, you run this program here. It's called RJ45. That'll redirect everything from the USB console to TX1, UART 1. And after you've written that and run it, then type tick. RJ45 is turnkey and then warm. So now every time the Scamp board boots up, it's going to run this program. It's going to set the UART baud rate of TX1 to 115.2K baud, and it's going to redirect everything from the USB console to the UART. Now to put it back to default, you press the reset button, and that will bypass the turnkey, and then type false is turnkey, and then warm, and then you'll be back to the default settings. Okay, here's a quick wiring diagram. So on the board, we have 6 pins on the top, 6 pins on the bottom, and here's our RJ45 jack with the 2 LEDs, the power, and the link. So we need 3.3 volts to 5 volts on this pin here. This pin is ground. This pin we hook up a push button switch. If we hold it down for 10 seconds to ground, it will put it into factory reset. So if you mess up the configuration, you can put it to factory reset. On the bottom, we have the TX LED with a current limiting resistor. We have our TX and RX lines that goes to the UART. And then we have the RX LED, and then we have a reset push button. Now a lot of this stuff is optional, so basically you need power, 3.3 volts and ground, and then hook up the TX and RX, and that will get you going. Okay, so that was my little tutorial on how to get your microcontroller project onto a network. Now if you go to the eByte website and search for NE2-T1B, you could download the user manual datasheet. And there's also other software there. There's configuration software. If you want to configure this module without using a browser, you could do that. So now you could take your microcontroller project and you could put it into the remote places and gain access through a network.